All right, guys. So here is a section on systems. Okay. So very first, this very first section here, very first part. All right. Oh, sorry. This very first part here, systems of equations. All right. A solution. All right. When we talk about a solution, we're looking for a point where when you draw on a graph, when you draw two lines, all right, a solution of the system is basically it's just where do those two lines cross. All right, that's really what a system, I mean a solution of a system is. All right, so a system is when you're graphing two lines. All right, that's all the system is. Now a solution is, again, where does it cross. All right, where do those two lines cross? Now, with this first section here, it says verify the given ordered pair is a solution of the system. All we're doing is just plugging in this ordered pair. All right, we're just going to plug in that ordered pair. We're plugging that ordered pair into these two equations. Now, it's a pain when they have them written this way. Really, what you'd rather have is you'd rather have them written next to each other like this. It makes the problem much easier. All you're going to do is you're going to take both of these numbers and plug them in. All right. 4 is x, 6 is y. So I'm going to plug in 6 is equal to 4 plus 2. And it's kind of a question mark because I want to know, does the left side equal the right side? Well, 6 is equal to 6. All right. So since those two equal, I know that that point, all right, I know that this point right here is on that line. Now I'm going to plug in over for the second equation. So y was equal to 6, 10 minus 4. And again, it's a question. Does the left side equal the right side? Well, yes, the left side equals the right side. Since since both of these work, we can say yes, 4, 6 is a solution to the system of equations. Okay, so again, since this point, since 4, 6, when I plugged it in for both of those equations, since I got both of these to equal the same thing on both sides, since they both equaled, I know it's a solution. If they don't equal, then it's not a solution. All right. So now let's come over here and let's try part B. All right. So again, rewrite it. It's kind of annoying that they have them written on top of each other. All right, but that's just to show that it is a system. All right, so let's plug in x and y. Remember, x is the first one. All right, so x is the first one. So 5 times 9 plus 6 times 2/3 is equal to 49. Well, 5 times 9, 45. 6 times 2/3 gives me 4. All right, and then again, this is supposed to be a question. So 45 plus 4, so 49 equals 49. So yes, that one works. All right. Now let's plug in the other one. So we have 3 times y. So you notice how they're trying to trick you here. Y came first, so you got to plug in. You got to be careful which ones you're plugging in. Minus 9. And does that equal -7? All right. So again, there's my goofy little question mark. All right. So right here, what happens? So I end up with 2 minus 9 is equal to -7. Yes, -7 equals -7. So then what can I say? Yes, 9 2/3 is a solution to the system. All right, easy enough. All right. So now here we get down to these two problems. We have to figure out what the solution is. So we have to graph both of these. Well, you'll notice for A, all right, for A, they were nice to us. Since we have to graph, they put them both in slope intercept form. So there's not much we have to do other than graph. All right, so y equals x. Well, you guys know that this is x plus 0. So where am I going to start? I'm going to start right there. I'm starting at the origin there. And then what's the slope? The slope is 1 over 1. So go up 1 to the right 1, up 1 to the right 1. We're just going to keep doing that. All right. And then since I can't use a straight edge here, I'm sorry, there's the best I can do. All right. Now let's get to this next one. Let's graph equation 2. All right, so I'm going to graph this one now. Y-intercept is 2, and now my slope is 3 over 1. So what does that tell me? I'm going to go up 3 spaces, 1, 2, 3, to the right 1. Well, so then I connect those two. All right, and since this is really, really horrible, I can actually go 1, 2, 3, and to the left 1, so that I can verify that yes, that I'm sorry, that my solution is -1, -1. Do you see where they crossed? You see that they crossed right there? Sorry, it is really hard to draw straight lines on this thing. Much worse than when I'm trying to draw straight lines on the board. All right, so it crosses at -1, -1. Now, how could I verify? Do like we did above. Plug those points in, make sure the left side equals the right side. All right, I'm not going to do it, you do it. All right, with these two. All right, so here's equation 1, here's equation 2. Well, if you notice, neither one of them are in slope intercept form. All right, you do it. Well, I don't want to take the time. I already did it. So equation 1 is y is equal to 1/2 x plus 2. All right. You guys go make sure you can remember, like see if you can remember how to do it. If not, send me questions and I'll do it real quick. All right. Equation 2, y is equal to 5 over 6x. All right. So let's graph this first. Oh, sorry. I guess I'm supposed to put the solution there. All right, let's graph this next one. So equation 1, I'm starting at the y-intercept, which is 2, and I'm going to go up 1 to the right 2. Don't screw it up and go 2 and then 1. All right, going up 1 to the right 2, up 1 to the right 2, up 1 to the right 2. And again, guys, I apologize. This is hard to draw straight lines on here. All right, so there's that line. And then the next one, equation 2. Well, my y-intercept is 0, so I'm starting at the origin again. Go up 5, right? 1, 2, 3, 4, 5, all the way over. And they made this one much easier for us. And I'm still not going to be able to draw a straight line, but there it is. What's my solution? It's right there where those two cross. So they cross at 6, 5. Oh, sorry. Guess I should be writing it down there. Okay. Now, over here, let's look at A first. All right. So I just want to look at A. Right. What is the solution to the system? Oh, where does it cross? It crosses at 2, 2. All right. It's crossing at 2, 2. Are the slopes of the lines the same or they're different? Well, the slopes are different. All right. They're different. Are the y-intercepts of the lines the same or different? Well, those are different also. All right. Part B. What is the solution of the system? Well, these two lines, do they cross anywhere? No, they don't. They don't cross anywhere. All right, they're not touching or crossing. So, what is the solution of the system? There's no solution. All right, no solution. Are the slopes of the lines the same or different? Well, if you go through and you pick 2 points, remember I told you guys just pick 2 points, make it easy for yourself. All right, there's 2 points. Goes down two to the right one. What happens if I picked 2 points there? Down two to the right one. So the slopes are the same. Are the y-intercepts same or different? They're different. All right, for part C. Well, what the hell? I only see one line there. Well, really what's happening here, guys, is there's two lines right on top of each other. There's actually two lines right on top of each other. And they call these lines that coincide. All right, so when there's two lines right on top of each other, the lines coincide. All right, so don't let it try to trick you and say, oh, there's only one problem, one line. There's actually two lines there. When I do it up on the board, if I were to do this for you guys, I actually draw. I will draw the two lines, but I won't I won't make them the same length. Right, so that's typically what I'll do. What is the solution to the system? Well, since these two lines are right on top of each other, it's infinite solutions. All right. Are the slopes of the line the same or different? Well, since it's the same exact line, the slopes are the same. Are the y-intercepts of the line same or different? Again, since they're exactly the same line, they're the same. All right. All right. So now we want to solve the systems by substitution. All right. So the other ones we did, where we were solving them graphically. Now we're going to be solving these algebraically. The trick when you want to solve them by substitution is you want to get one of the equations. You want to get one of the equations to get the variable by itself. All right, that's the whole trick to this, is get the variable by itself. All right, and that's going to make the problem a little bit easier. So let me erase that mess. What I'm going to do is, you see they gave us this little goofy line here. All right, separate the problem just like I did up above. All right, separate those two equations. Well, since I already have this variable by itself, I'm gonna take I'm gonna take. Sorry, I'm trying to see if this will help here. I'm gonna take x minus one, since y equals x minus one. I'm gonna take x minus one and I'm gonna plug it in for y. All right, so I'm gonna replace y. I'm getting rid of y and replacing with x minus one. So I have 2x minus 3 and open parentheses x minus 1 is equal to negative 1. Now you'll notice right here, you'll notice right there, there's no more y's. All right, y is gone. So let's solve just like we've always done. All right, so I have 2x minus distribute 3x plus 3 is equal to negative 1. Combine like terms. 2x minus 3x gives me negative x plus 3 is equal to negative 1. Subtract 3 from both sides. All right, so I want to subtract 3 from both sides. So I have negative x is equal to negative 4. And since I have a negative in front of the x, think about just doing the opposite. So positive x is equal to positive 4. And now that I know, oh, now that I know what x equals, I want to take x. I want to take this 4 and I want to plug it in into my other equation. All right. So I have y is equal to 4 minus 1. So y is equal to 3. The solution, remember, it's always x then y, 4, 3. All right. So there's my solution. Now let's look at B. All right. Again, we look at it. You'll notice neither one of them have a variable by itself. So we have to do that. All right. That's going to be your job. 3x minus 4y is equal to 12. 6x plus 8y is equal to 0. All right. Now, if we were in class, I would have been asking, all right, what do you want to solve for? Well, since there's nobody here to ask, I want to make the decision. I'm going to solve I'm going to solve equation 1 for y, right? I want to get y by itself. So for you guys that are struggling with this, let's add 3x to both sides. So I'm going to take this 3x and I'm going to move it over to the other side. So I end up with negative 4y is equal to positive 3x plus 12. Now I'm going to divide everything by negative 4. I hope I don't run out of room here. Y is equal to negative 3 over 4x minus 3. Well, now that I know what y equals, all right, now that I know what y equals, well, what does y equal? Y equals all that mess. I'm going to take this and plug that in for that y. All right, so 6x plus 8 times negative 3 over 4x minus 3, and that all equals 0. Of course, I run out of room. All right, now I have to distribute. All right, distribute that 8. So, oops, sorry, it's going to be a minus. So 8 times negative 3 over 4 ends up giving me negative 6x. 8 times negative 3 gives me negative 24 equals 0. Well, you'll notice right here, 6x minus 6x, these two cancel each other out. So I'm left with negative 24 is equal to 0. All right, when that happens, when the variable drops out, it goes away, it gets canceled. We have to look at this. We're looking at this and saying, all right, is that a true statement? Does negative 24 equal 0? No, negative 24 does not equal 0. So the solution is there's no solution. Because what ends up happening is if I were to solve both of these for y, if I were to solve both of these for y, if I looked up here, no solution, these two lines right here, all right, I'm hoping you guys can see my cursor. I really hope you can. Those two lines right there are actually going to be parallel lines just like B, all right? So there's no solution. Those two lines will never cross. All right. For C, I'm going to let you guys do it. But again, it'll be no solution. And then for D, all right, let's do D because this one's going to be a little bit different. All right, so you'll notice that they actually did solve one of these for y already. All right, they were being nice. Y is equal to negative 2x plus 4. And then over here, we have 7y is equal to negative 14x plus 28. Well, again, what am I going to do? I'm going to take all of this because that's what's y is equal to it, and I'm going to plug it in over here into this other equation. So 7 times negative 2x plus 4 is equal to negative 14x plus 28. Distribute, I end up with negative 14x plus 28 is equal to negative 14x plus 28. And I'm hoping you recognize that both sides of the equal sign are exactly the same. All right, so these things are identical. If I can spell, all right, these two sides are identical. So when the sides are identical, we would say that these things are the solution is infinite solution. All right, infinite solutions, or sometimes you'll hear math teachers refer to this as all. Oh goodness, all real numbers. All right, you'll hear them refer to it as all real numbers. Well, what happened here? Since both of these sides are exactly the same, infinite solutions, the two lines coincided. All right, the two lines were right on top of each other. If you solved both of these for y, all right, if you solved both of those equations for y, you'll notice that the slopes are the same and the y-intercepts would be exactly the same. All right, so if you want to verify that, just right here, I hope again I hope you can see the cursor right here. Divide everything by 7, and you'll notice it's exactly the same as this. All right. Hope that helped, guys.